Hello everyone, and welcome to another episode of BMED 202. In the last video, we looked at solving for resultant forces using the parallelogram of forces. Now, for that video, that method can be used regardless of the two forces, the directions, and the magnitudes. Now we are going to look at the triangle of forces and how we can use that graphical method to solve for equilibriant forces. If we remember from the last video, well, not the last video, but the last video that was made to make you aware of the different names of the different forces, you will know that the equilibriant force is the force that is required to bring a body in equilibrium. So whenever a number of forces are acting on a body, taking it out of a state of equilibrium, meaning it is now in a state of motion, once you add that force to bring it in equilibrium, that force is referred to as the equilibriant. So now today, for the same forces, the same scenario, we are going to now solve for the equilibriant force rather than the resultant force. So we are going to use the same image or same graphical representation of the forces. So this is the body. The body would be here. At this point, the forces are acting in their respective directions and magnitudes. So let's solve for the equilibriant using the triangle of forces method. Now, this is what we are going to do. We can start with any vector, and where one vector ends, so this would be the starting point of this vector, the ending point of this vector. This vector here, this would be the starting point, this would be the ending point. So this is what we're going to do. We're going to take any one vector. Let me take a copy of this vector. Place it here. We're going to take the second vector, and where the first vector ends, which will be at the arrow, we are going to start the second vector. So this is the starting point of the second vector, and place it at the end point of the first vector. Okay, so those are the first two vectors. Now, you have to use a third vector to create a triangle. So I'm going to draw a third line, and this line will be the equilibriant line. So let me select a different layer. So I'll put it here at the ending of the second vector. And this is my third vector, which is my equilibriant vector. Now this vector, if you notice the triangle of forces, all the forces are going in the same direction. It doesn't matter if it's clockwise or anti-clockwise. In this case, we started here. So this is an anti-clockwise motion. If we had started, no, sorry, this is a clockwise motion. If we had started with this vector, because as I said before, it doesn't matter which one you start with. Let's say you started with the smaller vector, which is this vector. Now you're taking the force based on the one you started with in an anti-clockwise motion. So that's the second vector. So please note starting point, ending point, which is the new starting point for the next vector. Let me go back to making the triangle. This is why it's referred to as a triangle of forces. So three forces forming a triangle. If you notice, both equilibriant forces from both diagrams, so the diagrams are situated a bit differently, but they are showing the same equilibriant force. Let's measure this line because remember the lines are directly proportional to the forces given the scale. So if you notice, the equilibriant force is 57.929 newtons, since we are converting millimeters to newtons based on the scale that we are using for this drawing. If you notice, both diagrams are giving you the same result. So this equilibriant force is 57.2975 newtons, or 57.3. Now, based on the previous lesson, you will notice something. This first video, or the previous video, the most recent video, we solved for the resultant force. Now, in this video, we are solving for the equilibriant force. And you can immediately notice that the resultant force and the equilibriant force are of the same magnitude. However, the equilibriant force is in the opposite direction, or going in the opposite direction of the resultant force, right? So let me show you how that makes sense. When a body is being burdened by a number of forces, all those forces combine, allowing the body to move in a particular direction. And all those forces give you what you call a resultant force. So these forces are acting at once. This is the force that is actually acting on the body as a result of these forces in their particular directions. Now, that body will be unstable or out of equilibrium. In order for that body to regain equilibrium, an equal but opposite force has to be added. So, if I had drawn a diagram, and let's say this was the diagram that I drew. If there was a third force to begin with, which was like this, from the get-go, this body would have been in a state of equilibrium, because these two forces would have given a resultant forces, would have given a resultant force in this direction, and then this force would have cancelled it out initially. So initially, this body, and you can do that with any of the two forces. If you find these two forces, the resultant of these, you will get a direction like this and a magnitude of this. And then this force will be the cancelling force. Let's say you are using these two forces to get the parallelogram of forces. You will find that the parallelogram, the diagonal for it, which would be the resultant force, would go in this direction, and then this would be the cancelling force. So it doesn't matter which two forces you use. The third one, in this scenario, based on the fact that I've worked it out already, you will get a cancelling force because the body is in equilibrium. All three forces are acting as such that there is no resultant force, or a resultant force of 0. Right? So in the last two, in this video and the previous video, you have learned how to use the parallelogram of forces to find the resultant force acting on a body based on the fact that two forces, you only use it for two forces. And in this case now, you use the triangle of forces to solve for the equilibriant. So the first two forces would be the forces acting on the body, and the third force would be the equilibriant force, which would close the triangle. I hope you have learned the concept. Please stick around for the next video, which will show you how to use the polygon of forces method to solve for the resultant force of a number of forces acting on a body. This can be 3 forces or more than 3 forces. Stay tuned, like, share, subscribe, share the knowledge, and have a good day.